Hello students, we are going to take notes on the reason for the seasons. And away we go. We're going to start here. We're going to start here. Most of you watched Bill Nye the Science Guy on Friday. And the awesome thing that Bill Nye does is he shows you with proof why the Earth's tilt causes the seasons. And he uses different ways, from painted lids to having motors running with solar panels. So those of you that were there, that should ring a bell. Those of you that weren't in class on Friday, you're going to take notes as well as everyone else in the room. Everybody takes notes today. We're going to start with this picture, and let me go bright yellow so we can see pretty well. All right, first and foremost, this time I've had you draw a straight line bisecting the Earth, but in this case, with this picture, I would appreciate you drawing a horizontal line bisecting the Earth. And I want you to put an N and an S, and an N and an S. N is for north, S is for south. Now, if you'd like, you can go ahead and bisect it one more time with a nice vertical line, all for Earth as it travels around the sun in 365.25 days. We've mentioned the 365 days before, but we haven't been as specific as to include the 0.5 days. Some of you are very much aware that every 4 years we have to include another day, and that takes care of leap year, because it does take 365.25 days to make one complete revolution. And maybe we should write, just because we're reviewing for our big test on Thursday, revolution of Earth. Okay, this blue line represents the tilt. So if I draw an arrow here, how many degrees is the tilt? 23.5 degrees. And notice that blue line is tilted. They're all parallel to each other as it travels around the sun. When it is tilted towards the sun, that means that that part of the Earth is getting direct sunlight. Direct sunlight. Therefore, in the northern hemisphere, it is summer for us. The opposite of summer, of course, would be when the Earth is on the opposite side of the planet. The opposite side of the sun, sorry. Here we are in the north, and look at the tilt of the blue line. 23.5 degrees away from the sun. Less direct sunlight. Less direct sunlight means shorter days, colder temperatures. So in the north, it would be winter for us. Now, winter and summer have very special names. It's called the solstice. Repeat after me, solstice. Okay, good. I know I'm in the room, so make sure you shout out when I ask you to shout out. And the summer, solstice. Why do they call it that? If you know your Latin and Greek well, sol means sun. And it doesn't matter the distance between the Earth and the sun at this point. When we talk about the reason for the season, it is all about the 23.5 degree tilt. Now, if we're not in the north any longer, so let me go purple, let's go back to summer for us. Now let's pretend we're in the southern hemisphere. And now, oh my goodness, look at that blue line. We are tilted away from the sun if we're from Australia or down under. If you're tilted away from the sun, that means less direct sunlight. And so for the southern hemisphere, this would be winter. Let's go over here. Winter for us in the north, but now I'm going to look at the south. And now here's the blue line, and it's tilted towards the sun. More direct sunlight for the south. So in Australia, it would be summer. So what's the difference between we have winter solstice and summer solstice? What is in between? We have the two seasons of autumn and spring. Now those have special names as well, and I'm just going to start with the first part of that name, equa. Equa means what? Shout it out. It means equal. So I'm going to finish the word with inox. You have the fall or autumn equinox and the spring equinox. So what do they mean by equal? Well, in this case, the tilt and the tilt is no longer tilting towards the sun or away from the sun, it is equal, which means in the fall and the spring, there are 12 hours of daytime and there are 12 hours of nighttime. Is that true for winter? Oh no, winter, much shorter days. That's why we had the time change on Sunday. We have to account for not as much sunlight during the winter time or the winter solstice. And then, of course, the summer, we have longer hours of daytime. So, distance. Do you remember distance? We have astronomical unit. The distance from the Earth to the sun is 1 AU, which is 150 million kilometers. Where'd they get that when we have a short distance here and a long distance here? Well, if you take these two distances and you average them together, that's where they came up with 150 million kilometers. This just reminds us that the Earth doesn't stand still. It's constant motion due to gravity. We have the rotation of Earth as well as the revolution of Earth. Now, as I look at the screen, and I'm asking you to try to take notes as much as you can, this one's tough. I've written all over it. So maybe it's best that I stop and look at another picture. A picture you can better understand in terms of solstice and equinox. All right, so wait, let's enlarge this picture just a little bit. If it lets me. It won't, but that's okay. Here we go. So for the December, or winter, for us, we are tilted away from the sun. For summer, we are tilted towards the sun, and we call those both solstice. Then we have March, and we have September, which is our spring and our fall. And of course, we call those the equinox, or equal. So look at that tilt for fall and the tilt for spring. It is parallel to Earth. It is not tilted towards, it's not tilted away, it's parallel. So equal hours of day and equal hours of night for both. Solstice and equinox. All right, let's check another picture. Let's try this one. Here we have planet Earth, and you see that it's naturally bisected by day and by night. Here is the 23.5 degree tilt, the reason for the season. If you know your geography well, of course, if you bisect it again, you have the equator. We have the Arctic Circle, the Tropic of Cancer, the Tropic of Capricorn, and the Antarctic Circle. It does depend where you are on Earth, what season you have. So let's quiz you and see how you do. Let's pretend you're right here in Africa. Look at your tilt. Notice that the sun is on this side. How do I know? Well, this half of the Earth is illuminated. Remember, lumen means light. So right here, it's daytime in Africa, and what season? If you're up here and you're above the equator, so this is north of the equator, hopefully you said summer. Now, if I'm still in Africa, but now on the southern tip, notice the tilt is away from the sun. So what season would it be? Winter. Let's see if I have another picture for us. I think that's it. Would you please repeat after me? The reason for the seasons is 23.5 degrees.